Imagine waking up tomorrow to find a pitch-black sphere with a glowing ring in the sky, warping the very space around it. To understand what happens next, we have to look at the invisible forces that usually keep us safe. For the last 4.5 billion years, our solar system has run with the precision of a master-crafted watch. The planets trace the same steady loops around the sun, day after day, year after year. However, the Milky Way is home to wandering rogue black holes. These are the remnants of collapsed stars that drift through the dark, completely untethered to any star system. While our solar system feels like a permanent, stable home, it is actually a delicate gravitational balance, one that is vulnerable to massive, invisible visitors passing through. This map shows the Oort cloud, a massive shell of icy debris sitting at the far edge of our solar system. If a wandering black hole headed our way, the activity would start here, at this outermost boundary. As the black hole enters this icy field, its gravity acts like a magnet being pulled through a pile of iron filings. It grabs hold of trillions of frozen chunks and yanks them out of their stable, lazy orbits. These displaced ice chunks are redirected inward, plunging towards the sun in a massive, coordinated wave. On Earth, the night sky would fill with a spectacular, unprecedented storm of comets. This sudden rush of icy visitors would be the physical evidence that an incredibly massive object has finally breached our cosmic neighborhood. Black holes are often described as cosmic vacuum cleaners, slurping up everything in their path. In reality, they follow the exact same rules of gravity as everything else in space. This comparison shows the sun next to a black hole of the exact same mass. Because gravity depends on mass, not size, the pole remains identical. If our sun collapsed into a black hole right now, Earth would continue orbiting in its usual path. The danger begins when a black hole travels into the immediate vicinity of another object. Imagine a rogue black hole passing near Jupiter. Jupiter is a giant, but a typical stellar black hole might only be a few miles wide. This image captures a black hole getting too close to a planet. Its overwhelming local gravity violently strips away the planet's outer layers. The stolen gas forms a tight accretion disk, crashing at high speeds to generate blistering heat and lethal X-ray radiation. Black holes destroy planets by getting so close that their densely packed mass simply overpowers the planet's ability to hold itself together. As the black hole nears Earth, extreme gravitational stress causes the entire planet to buckle. The crust cracks open, triggering global earthquakes and surface magma. This isn't just simple gravity at work. The planet is being torn apart by a specific phenomenon called tidal forces. We experience mild tidal forces every day. The moon's gravity pulls slightly stronger on Earth's near side, drawing oceans outward to create tides. But replace the moon with a black hole, and that gravitational gap becomes catastrophic, growing into a violent, destructive stretch. The side of Earth facing the black hole is yanked much harder than the far side, that the solid rock physically bulges and eventually snaps under the pressure. The true threat of a black hole is the extreme difference in gravity it creates across the width of a single object. Approaching 19,900 kilometers from the black hole, Earth crosses the Roche limit. At this threshold, tidal forces exceed the gravity holding Earth together. The planet crumbles, turning from a solid sphere into a scattered ring of debris. If you were to fall toward the black hole feet first through that debris, you would feel those same forces acting on your own body. Physicist Stephen Hawking popularized a specific term for what happens next: spaghettification. This diagram maps out the biological mechanics. Because your feet are closer to the black hole than your head, gravity pulls on them millions of times harder, stretching you out. Simultaneously, the forces squeeze your sides inward, compressing you into a thin strand. Crossing an event horizon means being stretched into oblivion, providing the ultimate proof of what happens when mass is concentrated into a single tiny point. This scenario is an extreme look at physics, but the actual probability of a rogue black hole entering our solar system is incredibly low. The vast empty distances of space serve as a natural defense. Most cosmic hazards remain billions of miles away, leaving our planet in peace. Black holes are simply extreme versions of the exact same gravity that safely pulls the tides on our beaches every day. They are a reminder of the powerful physics that govern our universe, even in its quietest corners.